Today, the ds-incubator continues with our series about the package targets. And I wanted to talk about some topics that are included in the chapter called Best Practices. That is chapter 5 of the manual of the targets package. The focus will be the idea of writing R packages or writing pipelines as R packages. And mainly because I know that a lot of us are already building packages, sometimes within the projects that host our analysis as well. But before we get deep into that, let me backtrack a little bit. Well, what you're seeing here is kind of the syllabus. We already covered the basics of targets. We covered how to mark different targets as outdated so that we could predict, for example, when make will recompute some target or will skip it. So we have covered the basics, and that's now a requirement to understand fully what's going on today, because I'm going to be covering more an infrastructural aspect of the targets package and not so much about how to define the pipeline. Also, a requirement. So today, sorry, there's so many requirements. So one is to have kind of watched any of the previous meetups, and second, to understand a little bit about the R package infrastructure. If you don't, that's fine. It might be the first time that you're going to hear about it. And if you have already built some package, I'm hoping that this will be particularly useful for you. And I'm also hoping that you may have lots of questions. So the benefit for us as a community of developers is that we could reuse the knowledge. I mean, the understanding the package infrastructure is a little bit of a steep learning curve. But the good news is that then once you get there, at least to the basic understanding of how to build a package, then it is very gratifying that you can reuse that knowledge in so many places. Our packages are the very main way of distributing our code. So, I can build just a little package and tell someone else, hey, you can just install it from GitHub with, say, DevTools install_GitHub and just the URL where it is, and you just get the package. So that's amazing because it's a super easy way to distribute code. Then there is also other benefits that some of us have already experienced, which is, for example, the idea that the package infrastructure, because it's so opinionated and so strict, has around it a set of tools like the DevTools package, the use this package, the test that package, the spelling package, and so on and so forth. So many packages that understand that structure and make your life as a developer a lot easier. And well, I kind of touched on that, just mentioned it, but the idea of testing as well. So as we build ever more complex packages, to make sure that we are not building on sand, we want to just write tests so that we can build on top of those of that code that we already built. So long story short, packages are everywhere, are pretty useful. If you haven't learned them, I recommend it because, as you can see today, even targets also can leverage the power of our packages that you build for yourself. So that's about it. So let's jump now to the project where I have some code to show you. The first thing I would like to do is to walk you a little bit through the project. Let's see if I can expand this. Yes, there you go. So this is a targets project. It is also an R package. So let me show you that a little bit. Why am I saying that it is a targets project? Because it contains a file called _targets.r. When your project has such a file at the root of the project, that defines the project as a target project. And what you can see here on the screen is that file opened. You may be already familiar with its structure. It starts with a call to library targets. Then usually you source any function that you need at the global level. And then, sorry, I'm commenting out code that comes from kind of previous meetups, and we are going to be focusing on the code that is not commented, but I'm going to cover that in a moment. Then we usually make a call to target options set to set options that apply to all of the targets globally. For example, we saw before how we can say, okay, packages equal tidyverse, which means use the tidyverse in all of the targets. Today we're going to be covering here, which I'm going to get to this in a moment. And then we have a list of targets. Each of these lines is a separate target. It has a name, it has an expression, and that's about it. So that is then why I'm saying this is a targets project. And today I'm going to show you how this project is also an R package. You don't have to do it this way. It's totally fine to have a project that only has a bunch of functions there, but there are benefits to building R packages, as I mentioned before. And what makes it an R package is really a file called description. This file here, which you don't even need to understand, really. You can, and I'm gonna link some resources at the end about where you can learn more about R packages. It is in the book R packages, and in particular the 2 chapters that I will point you to. But basically, you can create an R package with use this create package. There is a function that's called like that. Or if you already have the basic infrastructure and all you want to do is to add that description file, you also have the function called use description. So both of the 2 approaches will create formally a package. You may need to tweak it a little bit to make it compliant with all the conventions that our packages have. Like, for example, you have to have a license. I mean, it's not strict for using the. So forget about these 2 folders here. I'm going to delete them to not confuse you. You may even use the package without it being perfect, but today I'm going to kind of do the real thing. So that file description is what defines the package. There is an R folder that contains a bunch of functions. In last time you saw that all functions were in a single file called functions. Today, just to kind of play the game, I'm separating each function in its own file, and the pipeline is pretty straightforward. What I'm doing here is I'm using a function called raw path that basically reads a CSV file that installs when you install the package and outputs a file. Actually, I could run this as it is. As you can see, the path to a file. Then that path can be used in the pipeline, similarly to what you saw last time. Last time, we just gave the name before. Last time we just hard-coded a path to a file that lived in the data folder. So this time I did it a little differently, just to show a different approach. And now the path comes from the output of this function, raw path. So see, here I'm loading all functions in the R folder, and I'm doing it right away with a keyword shortcut, Shift-Control-L, which runs a function from DevTools that is called load all. So that is the same as sourcing every single function in the R folder. So that is one way in which I benefit, for example, of the tooling around R packages, just by pressing a keyword shortcut and having every function available to me. So now I could run then the function raw path, and there you go, you see the output, right? So with this, if you remember from last time, you can create a target that contains a path, and then that path can be used to feed any other item in the pipeline of targets. So here, once I outputted the path, then I'm using that path to read from there, and the function read, let's open it and see what it is. There you go. It is simply a call to read CSV. This is kind of a toy example that saves the reader of the output of a lot of messages that come with that function. If we kind of know what's going on, we can use read calls, which will make the output quiet. So again, I'm not very interested in kind of showing the details of this function, showing you, how with the package structure, things can be organized a little more neat, a little neater. For example, as I said before, each function can live in its own file. They can have documentation, right? So I could use, because this is an exported function, for example, I could use question mark and the name of the function, read, in this case, and that will give me a health file. Exactly the same thing that I wrote here now appears here as a health file. So that's another benefit of using an R package. I have examples that are executable, so I can just highlight the example section and press Control Enter, and that will be put right away into the console, so I can see the output of my examples. So beautiful. So with that, I'm hoping to have made a point that creating an R package is a good idea, maybe. And also I wanted to clarify that for simplicity for this demo, I use the same project to host both the pipeline, the targets pipeline, and the R package, but it doesn't have to be that way. The R package could be completely an external project, making your work even more modular. And then the big question, the focus of this meeting today is like, how do we actually use the package in our pipeline in a way that when the package changes, the pipeline also gets outdated. So basically in this particular case, we want to create a dependency between the package and the pipeline because we want to tie them together. We are developing the source code that feeds the pipeline as an R package. So we want to benefit from the structure of the R package, but we don't want to lose the ability to keep them connected, so that when we change the code, we want the pipeline to be outdated and then to recompute what needs to be recomputed and to skip what doesn't need to be recomputed. So let me get to that point now. So to kind of show more clearly what I intend to show, let me just start removing things that we already covered from last time. So this idea of sourcing our files is no longer necessary, so we can clean that. And why? Well, because we are going to bring source code not by sourcing an R folder, but instead by using the namespace that the R package provides. This is a little bit of jargon again. I anticipated that there is like a requirement to understand our package development a little bit. So sorry if I lost you already. But for those who already are familiar with our packages, hopefully this will make more sense. Again, last time we saw that we could use a global setting for targets to say which packages need to be attached. Well, now we can also get rid of that because our package may already, so in the description file basically of our package, let's open that file. Where is it here? Description file here. The description file has a section called imports. It can also have a section called depends and a section called suggests. Here is depends. And all of those sections allow you to control which dependency, which packages your package depends on. So now we don't need to use that call to options type diverse. Our package already is aware of which packages it needs. So now the way in which we tell targets that we want, there's two ways basically to create that connection between the R package, which in this case lives again inside the project, but it doesn't have to be that way, and the pipeline. So one way is to define the environment that contains, in the same way that the global environment is the environment that you might be kind of more used to because, it puts objects here in this little tab. There's other environments. There's the environments of an R package, for example. So you can define an environment as the environment where the package actually, or define an environment that contains all the names that exist in that package, that every object that package contains is available to you. So this is how I am defining the link between the package and this targets pipeline right now. And we have to do this kind of weird call to the function namespace. So basically this get namespace function, when you give it the name of an R package, it knows, it creates an object that is special in the same way that there is a data frame, for example. Well, there is an object that is called an environment. This is what it is. And when you print it, this is all you get, just the name of this little string of text that explains a little bit what that object is. And with that, every object that lives in the package is now available to be used in our pipeline. So again, remember, it doesn't have to be in the same folder. It could be a package that, as long as it is installed in your computer, that's fine. It could live in any other place of your computer. So now these objects are coming from the R package. So to kind of show more clearly that, let me restart my session, right? I'm gonna be using targets. So I'm gonna do library targets. And what I want to do now is I want to make the pipeline. So I'm gonna do tar make. And that shows that all the targets have been skipped because I have recomputed that a moment ago. So just to restart from 0, I'm going to do a tar destroy, which will remove the targets, the underscore targets folder. And I'm going to recompute with tar make. So this should create every target again. So as you can see, because this didn't fail, it means that all these objects targets knows about. And where are they coming from? Well, they are coming from this environment that we define here at the top. So now let me show you, let me prove that there is a connection, that if I change the source code of any of those functions that the package contains, that the targets pipeline will be outdated. So let's change, let's say, this read. Remember that targets is monitoring the source code of each function. So if I write anything that is meaningful, anything that is not just white space, something like hello here, now the function read should be out of date in the package environment, and then targets should be aware of that. But that won't work right away. So let me show you why. First, let me show you that this. If I ask tar outdated, it should tell me 0, because even when I have made the change in the source code, I haven't installed the new version of the package. So if you wrote packages before, you may know that there is a little click button here, install and restart, that will look at the source code of the package and install it. So now that package with the new source code, with the code that now has a new string, now is the one that is installed. So that means that now only now targets will be noticing that the source code of that function read has changed. So if I do now tar outdated, it looks like I need to first attach the package again because I have restarted. Yeah. So now I'm going to do tar outdated, and I see that 2 objects have been outdated. Raw, because I changed the source code of read, and also data, because it is a dependency. So the function clean is a dependency of raw. So everything from there and downstream has been outdated. In about a minute, I'm aware that Jakob is going to, actually now, he's going to kick me out. Are you there, Jakob?
Yes, it's 20 past now.
Perfect, thank you very much. I will take maybe 2 more minutes to show a simpler way to do the same thing, and the priority in which those 2 ways work. So there's another way to create that connection between an R package and a pipeline, and that way is, so let me comment one of these out. That way is with the argument imports. And import is simpler in that you don't need to do all this weirdness here. You just say which package you want to import, and targets will do just that. So let me run tar outdated. It's working. Let me run make. It should read. Could not find the function read. I know what's going on here. Blah, 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 blah. Interesting. So import read. I'm gonna now, actually, I'm not very sure what happened there, so I'm gonna restart. I'm gonna install the package again. and I'm going to library targets, and now I'm gonna do tar make. Let's see. Could not find a function read. Could not find a function read. That's interesting. Imports. Ports. Yes, that is. Honestly, I'm not very sure what's going on. Maybe I'll need to kind of find out later. Actually, I wonder if this actually works here. Let's see. It looks like it's working with environment, but not with imports, at least not as I thought. So I'll figure that out later and report to you next time. And also I want to say that there is a priority. So each of these approaches, the one that it is working now, the get namespace and the name of the package, and the approach with imports, have a priority. So first, targets will look for objects in get namespace, so in the environment argument. I will override any conflicting name that may come from other arguments. So you may remember, for example, that there are functions that have the same name in different packages. For example, plier and dplyr both have the function summarize. So which rules govern which object actually wins? Well, when you attach packages, the package that wins is the one that you attach last. But in targets, in this particular case, there is another set of priority rules. So envir, the argument envir, it wins over whatever you pass in the argument imports. And in the argument imports, you are not limited to just one package. You can basically you can depend on more than one package. You can depend on an ecosystem of packages, and the order in which you list them is the order in which one will override the other one, with the ones to the left having priority over the rest. Okay, so with that, I'll stop, and I would like to hear your questions and comments. So let's do a little round of voices. I have Jakob first. You can pass or you can ask or comment.
Yeah, that sounds cool so far. I think I would be interested to hear a bit more on how to integrate multiple workflows that do different things. Yeah, that's a good question, CJ. I was actually also wondering about that. Yeah, well, I mean, how we can basically do this for multiple different workflows in one package, so to speak. If you think about the stress testing repo, like there are quite a few different workflows, and of course, if I would do this, I would like to do that for all of them, but they're surely not all one pipeline.
Great, thanks. Yeah, I think we touched on that, but I haven't covered that in full. Basically, you can create a superset of targets, and then you can imagine different R Markdown files, each for one workflow, and each would use just a subset of the superset of targets. So basically, targets under the hoods, under the hoods would be just recomputing whatever needs to be recomputed and skipping whatever needs to be skipped. And then your R Markdown files are just simple calls to tar read or tar load to just use the targets that have been already computed. But I think there's a whole chapter about that, and I was thinking of squeezing it with today's meetup, and I wasn't able because of the lack of time. So probably, seeing that there is interest, and I think it is an important topic, I may add that to the syllabus. Claire, you're next.
Thanks, Mara. Nothing to add.
Thank you. I also acknowledge again that this is it's a topic that's very focused to kind of package development, so you may not have a lot of questions here now. I have here next Constanza.
Yeah, I'm not super familiar with writing a package, so some of this was new to me. I have to keep reading.
That's okay. I mean, it's not compulsory or anything. And in our team, we have analysts, we have engineers, and we have both people that have both interests. And I think that we can make our best work by like everyone working in their area where they are experts, right? So it's great, I think, to share knowledge, but as long as we complement each other, we are going to be working at our peak, I think, of our abilities. Monica?
Yeah, to be honest, I'm now like trying to figure out the testing of our packages. So this was too much for me. Like I couldn't take it. But I think it's cool once you get more like comfortable with just making a package.
Great, yeah. I mean, probably with that, the hook that I have for you right now is that if you embrace the idea of testing, then, I mean, that's something that, I'm totally hooked, of course, and I can just not live, I can not sleep, if I find, publishing code that faces the public and has no test. So that is why, every code that I write that faces the public has to have some tests. So if the code that I'm writing is also a targets pipeline, then how do I do the two things at the same time? And this meetup answers precisely that question. So how can you write code so that you can benefit from all the perks that come with our packages, including testing, and still have it connected strongly with the analysis, right? So the code is like the software infrastructure, like the engineering side of things, but then we have an analysis, like Jaco is using the word workflow, right? So we have those workflows that use the software that we write in a particular way to answer a specific research question. So with this approach, we can have the best of both worlds, basically. We can develop packages, or we can develop the infrastructure in the format of packages so that we leverage all the power that packages have, and we can use that, tightly connected with a targets pipeline so we can benefit from skipping or recomputing things that are expensive. So with that, in any case, this is a long conversation. I'm also very new to using targets in this setting, but I think we're going to follow up. CJ.
Yeah, so really quickly I made a comment, but for some reason in this Google Meet I can't raise there's no button to raise hand. I don't know if that's because you make this event on your personal account versus your 2DI account, or it's old account and maybe you need to remake the meeting. Anyway, just thought I'd mention that if you want to look into that, because it's kind of weird. It's not there. In terms of questions about this, so I had a question, and honestly I got distracted a little bit halfway through this, so sorry if you already mentioned this, but I was curious why you don't just use like a library ds.targets to load the library, to load the package in like a normal way, rather than, it seems like, jumping through some hoops with using the get namespace and importing specific names. So that was my question. Then also I was going to say that this stuff is actually very near and dear to some stuff I'm working, so I do appreciate the looking into interfacing between targets and packages, because that's kind of a bit of a struggle that I'm going through at the moment.
Yeah. So I think, to paraphrase your what you're saying, I think if I interpret correctly, the question is, well, why are we not doing something like packages ds target as opposed to, right? Why are we doing this as opposed to this? And the answer is that this in line 4 will work in that it will bring the source code and will make it available will make the functions available, but it is not going to be targets is not going to be observing for changes in the source code. So the reason why we might want, in some settings, want to do this is in the cases where we identify that there is a package within our analysis and we want to extract the code while keeping the connection between targets and the source code, so that targets is aware every time we change something that the target that is created with that function from an external package has to be outdated, so that it's recomputed when we run the pipeline. Is that?
Yeah, great.
Yeah.
Yeah, this is where it was getting dicey for me, knowing when changes are happening or not change, or when targets would notice when the changes. So that's I hadn't looked at this path. I will look into that.
Yeah, I mean, to me, still my mental model is very broken, right? I'm just learning this as we go. So only last week I learned about TarQ, which defines the rule to outdate targets, and now I'm learning how to integrate it with an R package. So my ability to kind of explain is very shallow so far, but the more we use it, I think the clearer it's gonna be. So any parting note, because I'm already beyond 2 minutes. I'll have to say goodbye. Anything to say before we leave? Okay, then thank you very much. See you next time.